Morning students, welcome to this video. In today's video, we'll be taking up the topic of Introduction to Trigonometry. There are basically two chapters based on trigonometry as far as your textbook is concerned. One is Introduction to Trigonometry and one is Some Applications of Trigonometry. Both of these two topics have a total weightage of 12 marks. You expect a question in all the four sections as per your CBSE board examination paper is concerned. You get a 1 mark sum, you get a 2 mark sum, 3 mark sum as well as 4 mark sum. Let's try to understand what this introduction to trigonometry topic is all concerned. This is all concerned with a triangle. The word trigonometry, it comes from two Greek words, trigon and metron. Trigon means triangle, metron means measurement. So this topic is all based with a triangle. Now what we have to do in a triangle, let's take an example. For example, you have a triangle ABC. In this triangle, we have three sides and three angles. The angles are being denoted by the capital letters A, B, C, and its sides could be denoted by the small corresponding letters. This side BC is opposite to angle A. I will denote it by letter A, small letter A. This side, as it's opposite to angle C, I will denote it by letter C, and this side is opposite to angle B. This will be denoted by letter B. That means three sides which are being denoted by A, B, and C, and three angles, they are being denoted by capital A, capital B, and capital C. These are angles. Now, these three sides and three angles, they sum up to 6 elements. They are known as elements of a triangle. Now, in a particular situation, some of the sides and some of the angles are given, and you are asked to find the remaining sides and angles. Let's take an example how this situation comes into existence. For example, you are in a garden. You see a tree that's quite lofty. You feel that how this height of this tree could be calculated without taking the pain of climbing the tree. Now, in this situation, if you are at a distance of maybe 7 or 8 meters from the tree, that distance could be calculated because that is accessible. Now you could see, when you see the top of the tree, you could make use of an angle measuring instrument like theodolite or sextant. There are many instruments. With that instrument, you could find the angle. That means you have an angle and one side. Situation is like this. If this being the tree, this distance, maybe this is 10 meters. This angle which you calculated using an instrument. So this angle, let this be 30, whatever it could be. Let's take 30. So one angle and one side is given to you. That means basically this angle is also given. So three elements are given to you, two angles and one side. And you have to find the height, this height of the tree. So this is a situation where some of the elements are given and some of the elements are to be calculated. In fact, you could find this height also, but we are interested in the height of the tree. Now, in such a situation, we take help of trigonometry. There are other situations wherein you get a right triangle or you get a non-right triangle and some of the elements are given and the remaining are to be calculated. So this area is known as solving a triangle. We call it as solution of a triangle. So trigonometry is used in solving a triangle. Now trigonometry has vast applications in different branches of science. It's mostly used in different branches of physics, be it theoretical physics, be it applied physics. It has vast applications in astronomy also. Astronomers have used in past to calculate the height or to calculate the distance of stars as well as planets. It has been used by surveyors also. It has been used by navigators. This trigonometry has application in astronomy. It has application in map making. It has application in different branches of science. Now, as far surveying is concerned, there's one important thing that I would like to share with you. In 1852, there was one great trigonometric survey being conducted in British India. In that, the height of the tallest mountain, which is Mount Everest, we know, its height was calculated. So from a distance of 160 kilometers at 6 different locations, the angle was being calculated. The person who headed that survey was Sir George Everest, and on his name that peak was named as Mount Everest. That was in 1856. Now we will be taking up T ratios which is the main area as far trigonometry is concerned. Basically, two tools are there. One is the Pythagorean theorem, and one is the T ratios. Pythagorean theorem and T ratios. These are two tools which trigonometry uses to find the height and distance of these inaccessible objects which we come into different situations. Pythagorean theorem you have already done in lower classes from grade 8th. You have been doing Pythagorean theorem. This is all applicable in a right angle triangle, provided two sides are given and you have to find the third side. Now this is something new, T ratios. T stands for trigonometric. What are these trigonometric ratios? They are also applicable in a right angle triangle. Now we'll be learning these T ratios, what we mean by T ratios. They are 6 in number, and today we'll try to understand what are these T ratios. Then we'll try to study the relationship which is existing amongst those 6 T ratios. Now what we do, we'll take a right angle triangle. Now if this is a right angle triangle, A, B, C, this is a right angle at B. Now angle A and angle C, they are both acute angles, as you know. AC is the hypotenuse. Now AB and BC, both of these are known as legs of a right angle triangle. This is one way of naming them, legs of a right angle triangle. Or if this angle is given, let this be theta, then this AB is known as the adjacent. You call it adjacent side. And there's one more name, you call it as base. So either you name it adjacent, means adjacent side, or you call it as base. Let's take this term base. Now this side BC, it's opposite to the acute angle, you call it as opposite. So this is opposite, or it's also known as perpendicular. Opposite or perpendicular. Let's take the term perpendicular. That means you have 3 sides of a right angle triangle: hypotenuse, perpendicular, and base. Now if I denote hypotenuse, if this hypotenuse is A, base is, for example, B, and perpendicular is C. That means this is A, this side is B, this side is C. So you have 3 lengths, A, B, and C. They are basically quantities, 3 sides of a right angle triangle. Now if we are interested in taking the ratio, how many ratios will exist? Let's see. One ratio will be A upon B, one more is B upon C, one more is A upon C. These are 3. Now reciprocate them, take the reciprocals. A by B, if you take the reciprocal, that will be B by A. This will give you C by B. This will give you C by A. So these 3 and these 3 total, they are 6 in number. Mind it, A by B and B by A, they are not same. So total are 6 ratios. So when 3 lengths are there, lengths of the sides of a triangle, or any 3 numbers are there, and if you take the ratios, you will get 6 different ratios. Same happens when you take the ratio of the hypotenuse, perpendicular, and base. So you get 6 such ratios, and these ratios are named as trigonometric ratios. So what are trigonometric ratios? In short, T ratios. Trigonometric ratios or T ratios, they are the ratios of the lengths of the sides of a right angle triangle, and they are 6 in number. And these 6 ratios, out of which 3 are main, basically you have 2 basic ratios and rest are known as higher T ratios. Now 3 are reciprocal of the other 3. Got it? 3 and their reciprocals. So you get total 6. Now these 6 ratios, they have been named. And they are named in terms of the angle. See, point is that if you take a bigger triangle, it's not that the value of the ratio changes. It remains same. It depends on the angle. So these ratios are named in terms of angle, and we'll list them. They are 6 in number. We'll list them. And you need to remember those 6 T ratios. So let's try to list these 6 T ratios. So order is important. Now the first T ratio, we call it as sine of theta. In short, SIN, it's not sin theta, it's sine of theta. Okay, next will be cosine of theta, in short cos theta. This is basically sine of theta. In short form, it's sine theta. This is cosine of theta. in short cos theta. Then third will be tangent of theta in terms of tan theta. Whatever angle you have, you will take that here. If it's alpha, then I have sine alpha. If it's A, then sine A, cos A, tan A, and so on. Now sine theta, cos theta, tan theta. Then fourth one will be, we can take cosec theta, and fifth one is secant theta, and sixth one is cot theta. Now, is this order, is the serial important? My dear friends, as per the first two are, in fact, first three are concerned, the serial is important. First is sine, second is cos, third is tan. And what about the remaining three? The remaining three, for example, I took the fourth one as cosec of theta. You could take cot. So you have a liberty for remaining three. Now I took cosec of theta because cosec and sine, they have a relation, which I'm just going to tell you. And cos has a relation with secant, and tan has a relation with cot. Now how you list the remaining three, that is your choice. But first three are to be listed sine, cos, and tan. Now we have to see what are their values in terms of the sides of a right angle triangle. Now my right angle triangle, which is ABC, so I'm taking this angle as theta. Now this is my hypotenuse, this is my perpendicular, this is my base, provided this is theta. I'm interested with this acute angle theta. Now sine theta is perpendicular by hypotenuse. It's perpendicular by hypotenuse. In short, P by H. I will teach you a way how to remember it. Cos is base by hypotenuse. Base by hypotenuse. In short, B by H. And tan is perpendicular by base. That means that the ratio of perpendicular to hypotenuse in terms of this acute angle theta, it has been named by mathematicians as sine of theta, in short, sine theta, not sin theta. And the ratio of base to hypotenuse has been named as cos of theta. This is co-function, I will come to that. Then you have tan of theta, this is perpendicular upon base. Now, how would you remember this in your examinations? There is a mnemonic. Mnemonic means a memory aid which is going to help. So with that memory aid, you have been doing memory aids in lower classes, like as per those, the distance of different planets from the sun. You retained that with my very earnest mother just served us served us noodles, whatever. There are different ways of retaining it. Now, how we retain the value of these t ratios? We retain it this way. So what you say, you remember like this, some people have, remember this phrase, some people have, it's a memory aid, curly black hair to present beauty. To present beauty. So by retaining this, you are retaining the 6 t ratios. Some people have curly black hair to present beauty. Now this will give you, S means for some. So some people, in short, write this. Some people have C, curly black hair to present beauty. That means your sine is P by H, your cos is B by H, and your tan is P by B. This way you will be retaining the value of these 3 t ratios. And the remaining 3, as I said, there's a relation. As for these 3 are concerned, they are related with these 3. So what we'll do, as you retain these, some people have curly black hair, so that way you will retain the value of sine, cos, and tan. Now, what about cosec? What about secant? What about cot? Now, cosec is the reciprocal of sine. Do remember it. These are reciprocal results. Cosec is the reciprocal of sine. That means its value is, you have to tilt it. It would be hypotenuse by perpendicular. And secant is the reciprocal of cos. Its value is hypotenuse by base. And cot is the reciprocal of tan. Its value is base upon perpendicular. Your main job is to remember the first 3. With the help of these 3, you will be listing the values of the remaining 3. I repeat, it's not that fourth has to be cosec always. You could take fourth as the reciprocal of tan. You could list cot here, secant here, cosec here, whatever you want. But do remember which 3 t ratios have relation with the remaining three ratios in terms of the reciprocal results. You call them as reciprocal identities. So we will just move further. In short, we will write them once more for your convenience. So we have observed what we have learned. We have learned that the value of these 60 ratios, the first one is sine of theta. Some people have sine theta is P by H. This is your first one. And second one is cos of theta, which is B by H. And third one is your tan of theta, which is to present beauty perpendicular by base. Now fourth one you could take the reciprocal of sine. If you take the reciprocal of sine, it will be cosec of theta. It will have to be hypotenuse by perpendicular. And if you take the reciprocal of cos, that will be secant of theta. That would be hypotenuse by base. And your sixth one is the reciprocal of tan. You call this as cot of theta. That is base by perpendicular. Now one thing as per the relationship, the properties of these 60 ratios are concerned, the first two are known as the basic T ratios. They are basic T ratios, and we say the remaining four are the higher T ratios. First two are basic, remaining four are higher. Why these are higher? They are higher because they are expressed with the help of the basic 2. I repeat, tan, cosec, secant, and cot are expressed in terms of sine and cos. That's why these are higher T ratios. We name them as higher T ratios. And the first two are the basic T ratios. Now, we have two types of results. One is the reciprocal result or reciprocal identities, and one more is the quotient result. So while listing these two results, you will come to know the relationship amongst these 60 ratios. That means higher have been expressed in terms of the basic 2. Now, we'll write that just here. If I write the reciprocal results, let me rub this full. The reciprocal results and the quotient results. My first will be the reciprocal results. Reciprocal results in T ratios, you could call them as reciprocal identities. My cosec of theta is 1 by sine theta. My secant of theta is 1 by cos theta. And cot of theta is 1 by tan theta. So you have expressed cosec in terms of sine. Cosec and sine are reciprocal. If we analyze it further, this means cosec theta into sine theta is 1. So sine theta is the reciprocal of cosec theta, and vice versa, cosec theta is the reciprocal of sine theta. Reciprocal means the multiplicative inverse. Cosec theta is multiplicative inverse of sine, and so is sine. And same is here, sec theta, in short we call it as sec theta. Secant theta into cos theta is 1, and this will give you cot theta into tan theta is 1. So this way also you could retain that the product of a T ratio with its reciprocal will give you 1. Because reciprocal, if you have a number, its reciprocal is a number so that the product is unity, is 1. Like 3, its reciprocal is 1 by 3. 7 by 5, its reciprocal is 5 by 7. Do just remember these results. We name them as reciprocal results. Then you have quotient results. Those are very brief, two results. Quotient, Q-U-O-T-I-E-N-T. Quotient results. Quotient results are your tan of theta is sine theta upon cos of theta. Quotient means you divide sine with cos, you will get tan. And cot of theta is cos of theta, because cot is the reciprocal of tan, so cot will be cos upon sine. So my dear friends, what I said just some minutes before, that sine and cos are the basic T ratios, because the rest of the remaining 4 T ratios, they are expressed in terms of the remaining. See, cosec expressed in sine, secant expressed in cos, cot expressed in tan, but tan in further expressed in terms of sine and cos. Now we'll move to the exercise. Well, exercise 8.1, this is the first exercise of trigonometry, introduction to trigonometry. In this exercise, you will be given a t ratio, a single t ratio will be given, and what you are asked to find out. You are asked to find out the value for remaining t ratios. Let's try sum of sums based on this concept. I'll be rubbing this. Now this is your exercise 8.1. This is the first exercise. Exercise 8.1. Let's see what's given. You have a right angle triangle, which is right angled at B. Okay. Now all sums will have a right angle triangle because it's all based on a right angle triangle. So I have a right angle triangle. PQR. No, that's a second. So my right angle triangle is ABC, right angle at B. So AB is 24, this is B. Let me take this as A, this as C. Now AB is given to be 24, BC is 7. AB is 24, BC is 7, and hypotenuse is not given. He says find the value of sine A and cos A. You are asked to determine the value of sine of A, cos of A. What else? Then you are asked to find the value of sine C and cos C. Sine of C and cos of C. Now the angles that are involved, they are all acute angles, but we do have a concept of T ratios for obtuse angles. That's in grade 11. So we are concerned with angle A and C, which are both acute and they are both complementary because they sum up to 90. Now to find sine of A, to find cos of A, sine C, cos C, I should tell you. Whenever you have to find any T ratio in terms of any of the two acute angles, you should be knowing all the three sides of a right angle triangle. Now in this right angle triangle, two sides are given, but third side is not known, so it's a case of Pythagorean theorem. I will apply Pythagoras theorem or Pythagorean theorem to find the third side. Then you could easily find the T ratios in terms of the two acute angles. Now in this triangle, if you apply Pythagorean theorem, your AC square is AB square plus BC square. So AC square will be AB is 24 square of that. This is 7 of square. This is 576 plus 49, 9, 6, 15, 11, 1, 12. This is 625 AC square. It's a perfect square. So AC is square root of 625, which is nothing but 25. My AC length is 25. So you have all the three sides of the right angle triangle. Now you could find sine of A. You would say sine of A is sine is perpendicular by hypotenuse. See, sine is some people have. People have perpendicular by hypotenuse, P by H in short. My P is 7 in this case and hypotenuse is 25. So sine A has value 7 by 25. No need to do the division. Just let it be in the P by Q format. My cos of A is base by hypotenuse, B by H. Do keep on writing B by H. That way things get registered in your mind. This is base is 24 by 25. Then you are asked to find sine of C. Now, a little bit attention to be given. Now, when sine of C is to be found, when you have this acute angle C, that time this is your base and this is your hypotenuse. Because when you had angle A, this was my base, this was my perpendicular. This time this is my base, this is my perpendicular. So sine is same, perpendicular by hypotenuse. P by H value doesn't change. Sine is perpendicular by hypotenuse. What is perpendicular in this case when you take angle C? When you take angle C, perpendicular is 24 and your hypotenuse is 25. And cos of C is base upon hypotenuse. Base is 7 and hypotenuse is 25. So these are the values for sine and cos in terms of the acute angle A and C. So this was a simpler sum worth 2 marks. Let's move further. Like question 2 is almost same. You have a right angle triangle in which you have to find the difference of tan P and cot R. Two sides are given. Now, we'll move further. Let me take question number 3. This was quite easy. Hope you have understood it. See, question number 3, question number 4, question number 5. They are all based on one particular idea that a single t ratio is given and you have to find the remaining t ratios. So let me take like question number 5. Here in you have one single t ratio given and you have to find the remaining t ratios. Like question number 5. For example, this is secant of theta is given to be 13 upon 12 and you are asked to find all 5 remaining t ratios. Same was question number 3 and question number 4. Let me read question 3 for you. Sine A is 3 by 4. You have to find the remaining 2 t ratios. Same is for question number 4. 1 t ratio is given. You have to find remaining 2. But in this case, 1 is given and you have to find the remaining 5 of them. A single t ratio given and you have to find the remaining. So the mind map should be like this. If a t ratio is given, with that t ratio, you will be asked to find the remaining t ratios. This is one way of doing the sums. A single t ratio given, with that find the remaining t ratios. So with this, what we do, we find remaining t ratios. Okay. Now, secant theta is 13 by 2. That means my cos of theta is 12 by 13. Because we are comfortable with the basic 2 t ratios, sine and cos. Now, if I have a right angle triangle here, this is theta. You call it as ABC, whatever you want. You could take PQR also. So cos of theta is 12. Now what is cos of theta? Cos of theta we know, sir, but cos is based by hypotenuse. Cos is based by hypotenuse. So that means cos is AB, base is AB, and hypotenuse is AC. Now, I just make an observation. So cos is given to be, cos of theta is given to be 12 by 13. But we know that cos is base by hypotenuse. That means this base is 12 and this hypotenuse is 13. This is one way of saying. This can be true in one particular situation, that base is 12, hypotenuse is 13. But since ratio is expressed in the lowest terms, that means that base could be 120 and hypotenuse could have been 130 also. When you divide 120 by 130, you get 12 by 13. So whatever common factor was there, that has been cancelled. Ratio is in the lowest terms. So we take this as 12x and 13x, or you could take 12k and 13k, whatever you want. Got it? So the common factor, we don't know what's the common factor that has been cancelled, because it's expressed in the standard form, in the lowest terms. So in one situation, base could be 12 units and hypotenuse could be 13, but not in all situations. We don't know what's the common factor that has been cancelled. We took that common factor as x or k, any letter. So that means if you make an observation, sir, AB is 12x and AC is 13x. So you have a right angle triangle. Apply Pythagorean theorem to find the third side. When you know all the third side, you could find all remaining 5 t ratios. So when we apply Pythagorean theorem, we get here AC square is equal to AB square plus BC square. Now AC is already 13x square of that, AB is 12 of x square of that, and BC is as it is, we have to find. This is 169x square, 12 square would be 144x square, plus BC square. That means 169x square minus 144x square is BC square. Simple solving of an equation. 9 minus 4 is 5, 6 minus 4 is 2, 25x square is BC square. If you make use of the positive square root, 5x is BC, so my BC is 5 of x. So we have succeeded in finding the third side. Now we could easily find the remaining t ratios. My secant was given, so my second t ratio will be basically the reciprocal of that. That is cos of theta, which I calculate. I don't have to find. So 2 t ratios are already there. That means I have to move on to the remaining one. So let me take the third one, that is sine of theta. Sine of theta is sine, some people have perpendicular by hypotenuse. Do write it, P by H. That is 5x by 13x. X cancels, so 5 by 13. Just when you found a t ratio, just after that find its reciprocal. That means my cosec of theta will be, it's a reciprocal of that, that will be 13 by 5. So this was 1, 2, 3, 4. I have two more. Fifth one will be the tan of theta. Tan of theta is to present beauty, perpendicular by base. This way, as you keep on telling yourself, things get registered and it's easy for you to retain it. That is 5x by 12x. So that is 5 by 12. And the last one is the reciprocal of tan, that is cot of theta, that is 12 by 5. So we have listed all the 6 t ratios, provided a single t ratio is given. My dear friends, if a single t ratio is given, do you know what's given? If you make an observation, single t ratio given means two sides of a right angle triangle are given. Because a t ratio is nothing but the ratio of the sides of a right angle triangle. Right? Ratio of the sides, the lengths of a right angle triangle. Two sides were given, sec was given, secant of theta was given, so two sides of the right angle triangle, you found the third side, and you found the remaining 5 t ratios. So this is one area, a single t ratio given. With that t ratio, you have to find the remaining t ratios. Now let's go to the other side of the situation. Rest of the sums are based on two different areas. I will be completing my mind map here. Hope you have understood this. I will be rubbing this and complete this mind map. A single t ratio given. Okay, sir, we found the remaining t ratios. What else? Again, a single t ratio given, one t ratio given. With that, what I do, I will be asked to evaluate t expressions. T expression to evaluate. What is a t expression? It's a trigonometric expression. I will explain that. And third area, again a single t ratio given. You are asked to solve. What? A t equation. This is equation. This is expression. This is equation. So your full exercise, this full exercise is based on these. We did the first one. One t ratio given, other t ratios to be found. Let's see how we evaluate t expressions and how we solve trigonometric equations. So let me first give an example what an t expression is and what is a trigonometric equation. My dear friends, in grade 9th, you have already done algebraic expressions. For example, 2x plus 7. It's an algebraic expression in one variable. It could be in two variables. Now, I have t expression. That means it will be an expression in terms of t ratio. Sine theta plus cos of theta. Or sine of theta plus secant theta plus 7. It's like that. So this is a trigonometric expression. An expression in terms of t ratios. And what is the variable here? Variable is theta, which you have to find. Here variable was your x. Okay, now let's move on to equation. For example, if I take the same expression, 2x plus 7 equated to 0. This is my equation, 2x plus 7 equal to 0. This is an algebraic equation. It's a linear equation, and when you solve it, you get the value of x, the variable. Now, sine theta plus cos theta equal to maybe 2. Right? So this expression, when you equated to some number, you got 2. So that means this is my trigonometric equation. And equations we solve. If I'm asked to solve this equation, that means I'm asked to find the value of the variable. Now equations we can verify also, we can solve also. We are not asked here to solve, basically we are asked to verify here, because if I have question number 8, solving equation is grade level concept, so I'm asked to verify or to prove. This is as per your level 10th is concerned. Trigonometric equation given, you are asked to prove it. Verify that left hand side is equal to right hand side. For trigonometric expression, you are asked to evaluate, find its value. Let's move to the second area. This we did. We'll move on to trigonometric equation expression. We have question number 7th based on this, and 9th is also 7th and 9th. Let me take question number 7th. It's a good sum. Cot of theta is given. Again, a single t ratio given in all these situations. A single t ratio. This is single t ratio. One t ratio given. Single t ratio given, and you are asked to do the remaining. Now I'll be taking up question number 7. What's given to me? Cot of theta is 7 by 8. Cot of theta is 7 upon 8. And I'm asked to evaluate 1 plus sine into 1 minus sine. You are asked to evaluate the value of 1 plus sine theta into 1 minus sine theta divided by 1 plus cos theta into 1 minus cos of theta. So this is a trigonometric expression and the variable is theta. You are asked to evaluate the value of this trigonometric expression, a single t ratio given. Now, if you make use of common sense, what we'll do, we don't have to find all the remaining 6 t ratios. Sorry, 5. One is given. So we'll be preparing those t ratios which we require. In this expression, you need sine of theta as well as cos of theta. So with the help of cot, with the help of one single t ratio, we'll prepare sine and cos, put them in this expression and do the simplification and see what is the value we are going to get. So I have my right angle triangle here. This is theta. Sine cot of theta is given. So I would say cot of theta, what is cot of theta? Tan is perpendicular by base. So cot is base by perpendicular. Tan is perpendicular by base, cot is base by perpendicular. Base in this case is AB. So base is AB and perpendicular is BC. So that means AB is, you could say, but cot of theta is given to be 7 by 8. So when you equate, so AB is 7x. And BC is 8x, as we did in the previous case. So AB is 7x, and BC is 8 of x. Okay? So we took the value of cot of theta, which was given as 7 by 8. We have put the values for the base and the perpendicular. We'll be doing a Pythagorean theorem to find the value of AC. Now in this, apply Pythagoras theorem. So AC square is equal to AB square plus BC square. So AC square is equal to AB is 7x whole square plus 8x whole square. Now AC square is, this is 49x square, right? Okay, plus 64x square. So AC square is 9411. This is 111x square. Sorry, this is 113. 13? Yeah, 113x square. What will be AC? It will be the positive square root 113x. Right? Square root of 113. X will be outside. So square root of 113x. It's not a perfect square. We can't find it. We'll keep it because we are going to get rid of this positive square root. I will tell you how. So you calculated the value of the third side with the help of the single t ratio. Two sides were given. Applied Pythagorean theorem to find the third side. Now you are in a position to find the value of any t ratio. We simply need sine and cos, which we are going to put in this trigonometric expression. So my expression is 1 plus sine into 1 minus sine. Let me cross check. Yeah, 1 plus sine, 1 minus sine, 1 plus cos, 1 minus cos. So I will keep it as it is. So this is my expression. Now what we'll do to make things simpler, let's first calculate sine theta value. Sine theta will be, because you need sine here and cos, sine is perpendicular by hypotenuse, it will be 8x by root 113x is gone. So its value is, sine of theta is 8 by root 113. And cos of theta is, what is cos? Curly black here, base by hypotenuse. In short, I will write cos is 7 by square root of 113. X has been cancelled in the numerator and denominator. So my sine of theta is with me. Same is with cos of theta. You need to put these values in this expression. But what we'll do, we'll try to save our efforts. If we apply a plus b into a minus b, famous identity in grade 9, a plus b into a minus b is your a square minus b square. Okay? Same is in the denominator, a plus b into a minus b. This is a square minus b square. Now, why we did it? We did it just to save the calculations, my dear friends. So, a plus b into a minus b, a square minus b square, this a square minus b square. Now, you put the value of 1 square means 1. Sine theta is 8 by square root of 113. You have to square that. So, that means I don't have space here. So, what I will do, I will rub this part and put the values of sine theta as well as cos theta. 1 square is 1 minus sine theta value is 8 by square root of 113, but it's square. See, sine square theta, what does this mean? This means square of the value of sine of theta. Not, you don't have to square the angle, sine square theta. It's sine theta whole square. And in the denominator, this is 1 minus cos of theta is 7 by square root of 113, square of that. So, if we do further simplification, I will take it here. So, this will give me 1 minus 64 by 113. If you square it, 68, it's 64 whole upon 1 minus 49 by 113. This is further, if you take the LCM, 113 minus 64 whole upon 113 divided by 113 minus 49 by 113. This 113 will go with this. When you take the product, you will take its reciprocal. So you are left with 113 minus 64 upon 113 minus 49. So you will get 13 minus 4, 9. This is 4 and this is 64. So this is 49 by 64. You can't do the further simplification. That is the value of this trigonometric expression. That was question number 6. A single t ratio given. You are asked to find the value of a trigonometric expression. Now its second part is cot square theta. This is quite easy. Cot square theta. Cot theta was already given. So you put the value and square it. So cot square theta will be cot theta whole square. So this was a square of the given t ratio. Now you have a similar sum, that is question number 9, which is on the same lines, a single t ratio given, and you are asked to find the value of the trigonometric expression. And what I will do, I will take the sum, then we'll move on to the last leg of this type of sum. Single t ratio given, you are asked to verify or prove a trigonometric equation. So we'll take, this is question number 9th, because 8th is a trigonometric equation. This is question number 9th, exercise 8.1. Question number 9 says that what's given? Given is in a triangle ABC, right angled at B, tan A is 1 upon 3. Tan of A is 1 upon square root of 3. Right angled triangle. So it's right angled at maybe B. So A is the acute angle. This is my C. Okay. So tan of A is 1 by square root 3. Now if tan A is 1 by square root 3, we know that tan is perpendicular by base. So tan is P by B. P is BC, B is AB. This is base. If you want to clarify, do write it. PERP, perpendicular by base. So, using the same logic, your BC is 1x and your AB is root 3x. So, perpendicular is this. 1x means simply x. This is simply x. This is square root 3x. X is outside the square root 3. You are asked to find the value of a trigonometric expression sin A cos C plus cos A sin C. Now let me first simplify this. So applying Pythagorean theorem, again AC square is AB square plus BC square. So AC square will be square root 3x whole square, and your BC is x square of that. So AC square is nothing but 3x square. This is x square. Further simplification, this is 4x square. So what is AC? It's nothing but 2x square root of 4x square. This is 2 of x. You have all three sides. What are the t ratios we require? We are asked to find the first part. Sin A cos C plus cos A sin C. Sin A, you are asked to find the value of this trigonometric expression. Sin A cos C plus cos A sin C. You are asked to find the value of this. Sin A cos C plus cos A sin C. So what you need? You need, in terms of angle A, you need sin and cos. In terms of angle C, again you need sin and cos. So we want sin as well as cos of A and C. So let's take the values. So what is sin A is perpendicular by hypotenuse. That will be x by square root 3x. That is 1 by root of 3. And let's take cos there also. So cos of A is base by hypotenuse. That's root 3x upon 2x. That will be square root 3 by 2. So we took A, we took sin A. Sin is perpendicular by, this is hypotenuse. I did it wrong. Sorry for that. Sin is perpendicular by hypotenuse. Perpendicular is this, hypotenuse is this. So it's 1 upon 2, and cos is base by hypotenuse, root 3 by 2. This is A. Now let's go to C, because you want C also. So cos of C, when you take cos of C, that time cos is base by hypotenuse. Base is that time x. When you take C, base, hypotenuse is 2x. So that will be 1 upon 2. And sine of C, sine is perpendicular by hypotenuse. In terms of C, perpendicular will be this. Perpendicular is this. By hypotenuse is this, 2x. So that is root 3 by 2. So you have these values for sine and cos of A and C. Let's put those values in this trigonometric expression. Sine of A is 1 upon 2 into cos of C is again 1 upon 2 plus cos of A is root 3 upon 2 into sine of C is again root 3 upon 2. If we simplify, this is 1 upon 4 plus 3 upon 4. That is 4 upon 4. That is 1. So the value of this trigonometric expression is simply 1. So that brought us to the end of this second phase, that is single t ratio given, how to evaluate t expressions. Now we'll do a sum based on a single t ratio given, how you have to verify, how could you verify a trigonometric equation. So for that we have question number, there's a single sum here, that's question number 8. Let's see what we do, how we work out that sum. So we'll rub this. Question number 8 says that if thrice cot A, this is question number 8. If thrice cot A is given to be 4, thrice cot A is given to be 4, you have to check whether 1 minus tan square A upon 1 plus tan square, you have to verify if 1 minus tan square A upon 1 plus tan square A, if that is equal to cos square A minus sin square A. Cos square A minus sin square A. So this is a trigonometric equation you have to see that if 3 cot A is given like 4, is this equation valid? So is 1 minus tan square upon 1 plus tan square A equal to cos square A minus sin square A? So what we'll do, we'll take the values of tan, prepare the left hand side, and the value of sin and cos, prepare the right hand side. If left hand side and right hand side are equal, then this equation is verified. It holds for that angle A. Now, this will be cot of A dividing both sides by 3. This is 4 by 3. That means your tan of A is simply 3 by 4. So you have your tan A ready. You could easily find the left hand side. But for right hand side, you need sin A and cos A. So we have to enter a right angle triangle, which we'll do. Right angle triangle is here. This is my A, this is B, this is C. Tan is perpendicular by base. So tan A is given. We'll say we know A is perpendicular by base. Perpendicular upon base. So perpendicular is BC, base is AB. So that means your BC is 3x. Your AB is 4. Your AB is 4x. Your BC is 3x. Find this has to be 5x because this is famous Pythagorean triplet. 3, 4, 5. They form a right angle triangle. Hypotenuse is the longest side. So when you do the working, you will say AC square in right angle triangle ABC. AC square is AB square plus BC square. So AC square, you have to do this for all sums. This is 4x whole square and this is 3x whole square. That means 16x square plus 9x square. That is 25x square. So obviously AC is 5x. Third side is 5x. So what we'll do, we have all 3 sides. We prepare the value of left hand side as well as right hand side and see the values. The sides have to be equal. So let's take the left hand side. My left hand side here is 1 minus tan square theta. Tan square A upon 1 plus tan square A. So left hand side is tan value is given to be 3 by 4. So this is 1 minus 3 by 4 square of that. Divided by 1 plus 3 by 4 square of that. So that is 1 minus 9 by 16. This is 1 plus 9 by 16. That is 16 minus 9 by 16. That 16 will go with this 16. And this is 16 plus 9. How much is that? This is 7 by 25. The denominator here cancels with the denominator. Denominator is the same, 16. So it will cancel. So 7 by 5, I got the value of left hand side. That means when you simplify, right hand side should also give you the same result. Let's put the values on the right hand side. So I'll be using this space here. I will have to rub this much. So my right hand side is cos square A minus sin square A. Cos square is base by hypotenuse. We could simply say, sir, this is 4 by 5. See, base by hypotenuse. X goes 4 by 5 whole square minus sine. Some people have perpendicular by hypotenuse. 3 by 5 whole square. X will cancel out, so I haven't taken that. Cos is base by hypotenuse. Sine is perpendicular by hypotenuse. Squared, this is 16 by 25 minus 9 by 25. 16 minus 9 is 7 by 25. So this is your right hand side. If we observe, call this equation 2. This was equation 1. So we say from 1 and 2, left hand side is equal to right hand side. From 1 and 2, left hand side is equal to right hand side. Hence, we have verified. Hence, verified. So what you have verified? We have verified that this expression is equal to this expression. So we have verified the equation. So with the help of a single t ratio, we have been able to solve this sum. Let's do one last sum of this exercise. That is question number 10th, based on the same concept. And with that, we'll close this video. This is the last sum for today. This is question number 10. So I'm rubbing this much. It says in triangle PQR, right angled at Q. Right angled at Q. PQR, let me take P here, R here, right angled at Q. What's given? In right angled triangle PQR, PR plus QR is 25 and PQ is 5. PQ length is given to be 5. Now, in this question, the sum of the lengths of the other two sides of the right angle triangle, they are given. So PR plus QR is given to be, how much? It's given to be 25. 25 units, 25 centimeters. We are asked to determine the values of sine P, cos P, tan P. So all three T ratios in terms of angle P. That means you should be knowing the lengths of all three sides. Then only we could find sine, cos, tan, because they involve three sides of the right angle triangle. Now, PR plus QR is given. So how should we move further? There are different situations. See, PR could be 13, QR could be 12, this could be 15, this could be 10, and so on. If I take this length as X, for example, so PR plus QR I supposed as X, this is 25. That means my PR is 25 minus X. So this length is 25 minus X. So now you have two sides of the right triangle in terms of X. We need to find the value of X. How will you find the value of X? If you have an equation in terms of X only. So apply Pythagorean theorem. So in right angle triangle PQR, in short, we write PGT, Pythagoras theorem, in short. So my PR square is PQ square plus QR square. My PR is 25 minus X whole square. My PQ is 5 square, and this is X square. So if you simplify, you have to make use of A minus B whole square. This is 625 plus X square, A square plus B square minus 2AB. 2 into 25 is 50X is equal to 25 plus X square. Okay? So A minus B whole square, A square plus B square minus 2AB. So this is a quadratic equation, but if you subtract X square on both sides, it reduces to a linear equation. So 625 minus 50X is equal to 25. If we further simplify it, my dear friends, it will give me 625 minus 25 minus 50x equal to 0. What I did, I subtracted 25 on both sides. So 625 minus 25 is 600 minus 50x equal to 0. Adding 50 on both sides. So 600 is 50x dividing by 50 on both sides. So that means 5 12s. So x is 12. That means this length is 12 and this will be 25 minus 12, 13. Therefore, your PR is 25 minus 12, that is 13. And your QR or RQ is X, which is 12. So this is nothing but this is 12 and this length is 13. So all three sides are given. What we are asked to find the value of sine P, cos P, as well as tan P. So we'll say sine of P. All three sides of the right triangle given, job is easy. Sine is perpendicular by hypotenuse. Sine is perpendicular by hypotenuse. Perpendicular is 12, hypotenuse is 13. And cos of P, base by hypotenuse. Base by hypotenuse, that is 5 by 13. And your tan of P is to present beauty, perpendicular by base, that is in short 12 by 5. So you have found all 3 T ratios which you were asked, and I hope that this video will be much useful to you when you watch this video. So we have been able to find different T ratios. We have been able to evaluate the value of different T expressions, and we have been able to verify a T equation provided a single T ratio is given. And when a single T ratio is given, basically 2 sides of the right angle triangle are given. Apply the Pythagorean theorem, you get the 3rd side. This is the gist of this topic, this exercise 8.1. So in my next video, I'll be taking up T ratios of specific angles, because there are different angles like 30, in fact 0 is also there, 0, 30, 45, 60, 90. That will be in the next video. So